system of linear equations. It is also application of matrix and determinants. In 10th standard, you have studied a pair of linear equations in two variables. For example, 2x plus 3y is equal to 7 and 4x minus y is equal to 6. So you can see here we have only two variables, x and y, and the remaining are constants. So now we will extend this the same concept to n number of linear equations and variables. That means now this x and y and z and so on will be replaced by x is equal to x1, y is equal to x2, z is equal to x3, and so on up to n variables. And similarly, there were only two equations. Here we can take 3, 4, 5, and so on. So that is called system of linear equations in n variables. So in this case, for example, like this 2x, we have the a11 first equation, and then x variable is denoted by x1. This x2 will be denoted, this y will be denoted by x2, and z x3, and so on up to n variables. And then this right hand side 7, 6 are being denoted by b1, b2, and up to so on. These are n equations with x1, x2, x3, x4, and xn with n such variables. These equations also in matrix form can be written as this way: a11, a12, a13, like this: a11, a12 up to a1n, and then a21, a22, a2n, and so on up to last this one ann. So in this case particularly, as this a11 constant, a12, a13, a14 first row or second row up to n terms, and similarly we have n rows. These are actually constants are being multiplied to these n variables. So this n variable x1, x2, and xn, we have this one multiplication. If we multiply these two, we will get this equation first, and the right hand side is equal to b1, b2, bn. That is similar to what we are writing now in matrix method: ax is equal to b. So means this is nothing but this is a matrix A, this is x matrix, and is equal to b. So A is equal to this constant, this is x, and this is b matrix. Now the next topic is classifications of system of equations as consistent and inconsistent. What does it mean? This when we are solving the linear equations in n variables, first I correlate with the 10th standard. When we were solving this linear equations in two variable, we had three options. One is unique solutions, second one is infinite solution, and the third one is no solutions. So when there was a chance of getting solutions, that means in both the cases, a first case that is unique solution or infinite cases, in both the cases such system of equations were called consistent. When we were getting solutions, doesn't matter whether it is one solution that is unique or infinite many. And inconsistent means when there is a no solution. When there is a no solution, we call that linear system of equations is inconsistent. That we are going to study in a detailed manner when we have n number of variables with n number of equations. A system of linear equations of n variables, what here we shall study only three variables, that is x, y, and z. In particularly in your class, is said to be consistent if and only if it has unique or infinite solution, as I said. And when this system has no solution, it is called inconsistent. So you need to remember this particular word. Inconsistent means there is a no solution. Consistent means when we have unique solutions or infinite solution. Now unique solution, in case of this matrix or in the form of determinant, when determinant is not equal to 0. When the value of a determinant is not equal to 0, then solution of system of linear equations can be found by the formula x is equal to A inverse B. Means in this particularly next few problems, we will be using this matrix method where x is equal to A inverse B is the formula for finding the solution of the linear equation system of linear equations in three variable, where x will denote three variable x, y, z. A will be denoting the coefficients of x, y, and z, and b will be the right hand side of the equations. If determinant of A means this one is equal to 0, there is a possible consistent or as well as inconsistent, means infinite solutions or inconsistent means no solutions. That we will study in detail later. When determinant of A is equal to 0, you need to understand there are so many options will be coming underway. So when determinant of A is equal to 0, you remember this thing, determinant of A is equal to 0. If determinant of A is not equal to 0, so simply you will use this formula, finding the inverse of matrix A and then multiplying with B. That will be your answer. That means the value of x, y, and z. That will be the end of the question, where you were asked to find out the value of the variables. But when determinant of A is equal to 0, in that case, we two possibilities. There will be two options. First one is you will be finding adjoint of A and multiplying it with the B, that is right hand side of the matrix. If it is equal to 0, then system may be consistent and may have infinitely many solutions. When you will be attempting the problems, you will understand the meaning of may. Uh, so you need to understand, I repeat once more, if this determinant is equal to 0, there will be a possibility of two chances. There will be two chances. The first one is adjoint of A into B is equal to 0. If it happens so, then the system may be consistent and may have infinitely many solutions. So consistent means there will be solutions. Or the second option, this if adjoint of this matrix A into B is not equal to 0, then system is inconsistent and hence no solutions. So no solutions means you need to remember this thing over here. If determinant of A is not equal to 0, simply there will be solutions, unique solution. And if determinant of A is equal to 0, then you will go for these two, either of these two options, maybe first one or maybe second one. If this is true, then there will be infinitely many solutions. If this is true, that means adjoint of A into B is not equal to 0, then the system is inconsistent and hence there will be no solutions. Now let us start exercise 4.6, and that is application of matrix in the form of determinant also. So here comes the first question, which is classify the following system of equations as consistent or inconsistent. So question number first is x plus 2y is equal to 2 and 2x plus 3y is equal to 3. So for the solutions, here we moves. The given system of equations can be written in the form of ax is equal to b, where this a is equal to 1, 2 and 2, 3, x is equal to xy and b is equal to 2, 3. Dear students, you have to keep one thing in your mind. Whenever you are attempting linear equations in two variable or three variable to solve, so you have to think about this particular formation, this particular statement, that is ax is equal to b. Every linear equation will be in this format, where a is purely constant, b is also purely constant, and x is all the variables involved in that particular question. So what is a? A is in the left hand side all the coefficients of the variables, and B will be all the constants in the right hand side of the equation. So what I told you here, what is matrix A? This coefficient of x is 1, coefficient of y is 2, so we are writing in first row 1 2, and the coefficient of x is equal to 2, the coefficient of y is equal to 3 in the second equation, so we will write it in the second row, that is 2 3. And how many variables are involved? X and y 2. So x, capital X, will be written as the column matrix x and y, and the right hand side which is matrix B. So B is equal to 2 3. So in this particular question you have to check whether the system is consistent or inconsistent. That's all only. You need not to solve it. So this we are going to find out the determinant, means the value of this determinant A, which is equal to this solving this 1 into 3 3, and then minus 2 to the 4. So 3 minus 4 is equal to minus 1. You need to be carefully over here. It should not be equal to 0. Since minus 1 is not equal to 0, so means this is a non-singular matrix, and non-singular matrix has always unique solution. So therefore, A inverse exists. We can also say that for that solution later on. Hence, the given system of linear equations is consistent. Solutions can be found by the formula x is equal to A inverse B. So that is what written over here. Now we take a question of order 3 by 3. Just short while ago we solved a question of order 2 by 2. Now we take of order 3 by 3. Order 3 by 3 means here we will have involvement of three variables x, y and z. So here comes x plus y plus z is equal to 1, and this x plus y plus z is equal to 1, 2x plus 3y plus 2z is equal to 2, ax plus ay 2az is equal to 4. We will go for the solution. So look at here, all the coefficients are 1 1 1, all the coefficients are constant 2 3 2. The first row will be matrix A's first row will be 1 1 1 2 3 2, and then A then 2a. Except variable you have to take everything, means except xyz and xyz you have to take everything, and this is B matrix 1 to 4. So the system of equations can be written, always you have to write as I told you earlier, Ax is equal to B, where A is equal to this one 1 1 1 2 3 2 2a, x is equal to x y z. How many variables are here? We have x3 x y z, so we have written x y z, and B is equal to the right hand side of the this particular question. So now determinant of this matrix, that is our now determinant of matrix, that will decide whether a system of equation has unique solutions or infinite, means consistent or inconsistent. For that we are going to find out the determinant, which is determinant of A is equal to, we are expanding it, you can see this 1 minus 1 plus 1, so expanding through R1, this R1. So determinant A is equal to 1 into leaving these two perpendicularly, then 2 3 is a 6a minus 2a. So this is 6a minus 2a, and then minus 1, this is leaving this way, 2 2 is a 4a, and then minus 2a, and then plus later on plus 1, this last one leaving this way, we have 2a minus 3a, 2a minus 3a, solving it, 6a minus 2a 4a, and then 4a minus 2a 2a, and then minus outside, and then plus 2a minus 3a minus a. So minus 3a plus 4a is equal to plus a. So Again, plus A is a constant which is not equal to 0. Therefore, the system will have solutions. So we can say that A inverse exists. Hence, the given system of linear equations is consistent. Solutions can be found by using formula x is equal to A inverse B. If it is asked, you can find out this solutions means first of all we will find out the A inverse and then multiplying it with B, and that is equal to x. That we will take, some questions we will take later. Just now we are just checking whether the system of these linear equations are consistent or inconsistent. Now we take a little different question where this determinant value of determinant A is 0. That means the matrix is singular. Now when matrix is singular, then let us see what will happen. So let us have a question 3x minus y minus 2z is equal to 2 and 2y minus z is equal to minus 1, 3x minus 5y is equal to 3. So we can write this question in this format where a is equal to all the coefficients 3. Now look at here 3 minus 1 minus 2, but in second case, second equation, this variable x is missing. In third case, the variable z is missing. So what does it mean? So now when this position, first position x is missing, so in place of that we will put 0. In second case, this z is missing, so we will put 0 in place of z. So that constant, that means 0 into z, something can be written here plus, and then 0 into x plus 2y minus z for the fulfillment of all the three variables. So 3 minus 1 minus 2 and 0 2 and minus 1 here, and then 3 minus 5, and then z is not there, so 0, and then x is all the three variable x y z here, and then b is the right hand side 2 minus 1 and then 3. So this is all about this question. Now let us try to find out its this determinant a is equal to expanding through this c1. Why c1? We have this 0 over here. So for that we will get the answer quickly. So the determinant a is equal to 3 times, so leaving this way 2 into 0 0, and then minus minus plus plus, and again minus minus 5 minus 0 in middle term, so everything will be 0, no need of writing, and then plus 3 last one, so leaving this way and this way, so minus into minus plus 1 and minus minus plus 4. So the result is minus 15, 3 into minus 5 minus 15, and minus 0 leaving, and then 4 plus 1 5 into 3 15. 15 minus 15 is equal to 0. So the matrix is singular. So this singular matrix, what I told you earlier, we will now find out its adjoint A. So for that, again for adjoint of A, how you will proceed? The same procedure what we had followed earlier. That means from matrix A, this we will start with cofactors, then A11, A12, A13, and then A21, capital A, okay, A22, A23, A31, A32, A33. Then taking all the cofactors with their sign, that means this is 1 1, so minus 1 to the power 1 plus 1 2, minus 1 to the power 1 plus 2 3, so negative sign will come here. Here it will be 1 3, so positive, 2 1 negative, 2 2 positive, 2 3 negative. Here third row and the first column 3 1 positive, 3 2 negative, and 3 3 positive. So accordingly putting all the this cofactors into that matrix and taking its transpose, that is called adjoint of matrix A. So that is equal to minus 5 minus 3 minus 6 10 6 12 and 5 3 6. This is adjoint of A. Now what is our next step? This finding this adjoint of A and the product of this B with it. So what is that? The same adjoint of A is this matrix, and the B matrix is right hand side, that is 2 minus 1 3 is equal to, now order of this matrix is 3 by 3 and order of this B matrix is 3 by 1, so the resultant matrix will be of order 3 by 1, 3 rows and 1 column. So the same procedure, multiplying this row with this column, so minus 5 into 2 minus 10, 10 into minus 1 minus 10, and 5 threes are 15, this one here. Next column, next row, sorry, and then next row here, 3 minus 3 into 2 minus 6, 6 into minus 1 minus 6, and 3 into 3 plus 9 over here. And the last row, minus 6 into 2 minus 12, 12 into minus 1 minus 12, and 6 into 3 is equal to 18. So minus 10 minus 10 minus 20 plus 15 minus 5, and this minus 6 minus 6 minus 12 plus 9 minus 3 minus 24 plus 18 is equal to minus 6. So this whole matrix is not a zero matrix. You need to understand over here, if determinant of A is equal to 0 and then adjoint of A into B, this should be matrix only, all the elements of this matrix are 0, then we say that this is zero matrix. But since now we have minus 5 minus 3 minus 6, this is not zero matrix, so this particular adjoint of A into B is not equal to 0. Since adjoint of A into B is not equal to 0, therefore no solution. Hence system of linear equation is inconsistent. Now we take some questions where in actual form we have to solve the equations and finding the value of variables. So we take question number 7. Question number 7 is this 5x plus 2y is equal to 4 and 7x plus 3y is equal to 5. So we have taken 2 by 2 matrix. So let us go for its solution. For we have A is equal to this 5 2, and the second row is 7 and 3. X is we have only two variables, so we'll write here x and y, and B matrix is, that is right hand side, 4 and 5, where Ax is equal to B, that is our question. So we have to find out x is equal to A inverse B. So for that we'll start with the determinant of A, where value of A 5 into 3 minus 7 into 2, 15 minus 14 is equal to 1, which is not equal to 0. What does it mean? Means this matrix is a non-singular. That means there must be unique solutions of this linear equation of two variables. So inverse exists. So let us go for the inverse. First of all, cofactors. So we'll start with the a11, which is directly here. 1 means minus 1 to the power 2. So directly we'll write 3 positive. 1 2 means this 2. So its position is negative. So its opposite symbol is 7. So minus 7. 2 1 again, this 7 negative position. So its opposite element is 2. So minus 2, and a22 is minus 1 to the power 4 into this 5 is equal to 5. Therefore, adjoint of this matrix A is equal to transpose of this all elements. We are writing in the same 3 minus 7 and minus 2 and 5. So we will write this row into column 3 minus 7 over here and minus 2 and 5. Now, A inverse, as we have written here, A inverse, first of all, we have to find out the inverse of this matrix, 1 upon determinant A adjoint of A, which is equal to 1 upon determinant A. The value of determinant A is 1. So 1 and then adjoint of A, this thing. 3 minus 7 minus 2, which is nothing but same matrix only. Thus, X is equal to A inverse B. Means this is A inverse and multiplying with this matrix B, 4, 5. So we are multiplying here 2 by 2 and this is 2 by 1. So the resultant matrix will be of order 2 by 1. So 3 into this 4, 12, and then minus 10, and then minus 28 plus 25, which is nothing but 2, and this minus 3, which is what is which is x, capital X actually, and that is capital X means all the variables involved in this question. So here we have two variables only, that is x and y. So for that we will compare these two sides. X is equal to plus 2 and y is equal to minus 3. So that's all about this question. Now in the same direction, let us take one more question of order 3 by 3. So we start question number 11. Question number 11 is 2x plus y plus z is equal to 1. X minus 2y minus z is equal to 3 by 2. And the third equation is 3y minus 5z is equal to 9. So let us go for its solution. So we start with the writing it in the form of ax is equal to b. So for that a is equal to this coefficient 2 1 1 here, 1 minus 2 and minus 1, 1 minus 2 minus 1 here, and 3 minus z. But you can see here x is missing, so in place of x we have put 0 and then 3 and minus 5 as it is. And this x matrix is all the variables involved in this question, x, y and z. And matrix B means the right hand side, that is 1, 3 by 2 and 9. Let us now go for finding the determinant. Determinant of this matrix A is nothing but 2 minus 1 0. So we are going to expand it. We are going to expand this determinant through the C1 because at the last we have 0. So we have the advantage of getting less calculation. So this 2 into leaving this way minus 10 minus minus plus 10 and then plus 3 and then middle term minus 1 leaving this way minus 5 and then minus 3 and the last one is 0. So here it is 0 is equal to 2 into 13 minus 1 into minus 8, which is nothing but this 26 and plus 8, which is 34. 34 is not a 0. That means this matrix is a non-singular matrix, means its inverse exists. So now if its inverse exists, so we'll go for the cofactors a11. Same procedure, a11 means this element leaving this way minus 10 and then plus 3 13 and taking the sign of all the element 1 2 means negative times leaving this way 0 into this thing and then so on up to last a33 over here, same way, same procedure, minus 4 and then minus 1 minus 5. So now we put all the elements in that format and then taking its transpose, that we will get this adjoint of matrix A. And you can see 13 5 3, these we had taken horizontally, but here you can see we have put it vertically. That means we have already taken transpose of this matrix, that is called adjoint of this thing, and we have applied this formula A inverse is equal to 1 upon determinant A into adjoint of matrix A, which is equal to the value of determinant is 1 by 34 we have already put here, and this thing, the whole adjoint of this matrix, which is equal to now 1 upon 34. Now this inverse we have already got, so now we'll go for finding the variable term, that is x, means value for all the variables x y z. So the formula A inverse into B. B is our right hand side 1 3 by 2 and 9 that we have put here, and this is 1 upon 34 into, don't multiply this 1 upon 34 inside, don't make this mistake, otherwise your question will be complicated. You keep it aside, keep it outside, and first of all you multiply these two matrices in all the questions, whether it is 2 by 2 or 3 by 3. Whenever you are solving for this 3 variable 2 variables by matrix method, never ever multiply this determinant, value of determinant inside when you are finding inverse. You will be multiplying, no doubt, at the end of the question after the multiplication of this inverse with the matrix B. So what do we do now? As I said, we will multiply these two. As I told you, 1 upon 34 outside, and then this 3 by 3 and 3 by 1. So we will have 3 by 1 matrix. So we will have 3 by 1 matrix. So this capital X, we have written X, Y, Z is equal to 1 by 34 as it is. 13 into 1, this one. 8 into 3 by 2. So 2 into cancel, 4, 4 3 is a, we have 12, and then 1 into 9, here we have 9. Next row, this 5 into 1, 5, and then minus 10 into 3 by 2, 2, minus 5 into 3, minus 15, and then 3 nines are 27. The last row, 3, last row 3 into 1, 3, and then minus 6 into 3 by 2. So 2 into this cancelled, 2 is minus 6 by 2, minus 3 into 3, minus 9, and minus 5 into 9, minus 45, which is equal to 1 upon 34 outside, and this is 13, 12, 25. 25 plus 9, 34, and then 27 plus 5, 32, minus 15, 17, and minus 50, minus 45, and then minus 9, minus 54, plus 3, minus 51. Now the time has come where you will be, now after getting this product in the form of 3y1, 3 rows and 1 column, single column, then you multiply this one determinant inside. Now 34 upon 34 1, 17 upon 34 1 by 2, and then minus 51 upon 34 minus 3 by 2. So here we have reached to the conclusion of this question. X is equal to 1, y is equal to 1 by 2, and z is equal to minus 3 by 2. So this is the solution of the system of linear equation in 3 variables by matrix method. So here comes question number 16. Question number 16 says the cost of 4 kilogram of onion and 3 kilogram of wheat, 2 kilogram of rice together is rupees 60, and the cost of 2 kilogram of onion, 4 kilogram of wheat and 6 kilogram of rice is combinedly rupees 90. And lastly, the third statement, the cost of 6 kilogram of onion and 2 kilogram of wheat and 3 kilogram of rice is rupees 70. Then the question is find the cost of each item per kilogram by matrix method. So here we will convert this statement, whole statement, into 3 linear equations, the solution. So let us suppose first of all that the cost of 1 kilogram of onion is equal to rupees X, and the 1 kilogram of wheat is equal to rupees Y, and that of rice equals to rupees Z. Then the 4 kilogram of onions, the total price will be considered as 4x. So we will be converting this whole equation statement into this mathematical statement, that is system of linear equations, as 4x plus 3y plus 2 uh, z is equal to 60, and then 2x plus 4y plus 6z is equal to 90, and then 6x plus 2y plus 3z is equal to rupees 70. Then the system of linear equations can be written in the form of ax is equal to b, where a is equal to matrix A is equal to 4 3 2 and 2 4 6 6 2 3. Matrix X is equal to, that is all the variables involved, x y z, and the matrix B is equal to the right hand side of this B matrix, that is 60 90 and 70. Now our next step is to find the determinant of this matrix, that is the value, that is determinant of A is equal to, so we are expanding through R1, this R1, so 4 times, leaving this way, 4 into 3 12, minus 6 to the 12, next is minus 3, and then leaving this way vertically, so 2 3s are 6, and minus 6 6 is 36 over here, and then plus 2 is this one, so leaving this way perpendicularly, so 2 2s are 4, this one 4, and then minus 6 4 is 24, so is equal to 12 minus 12 0, plus 6 minus 36 minus 6, that is minus 30, and then minus 3 multiplication, that is 90, and then plus this 20 into 2, 40 minus 40, so 90 minus 40 is equal to 50, which is not equal to 0. That means this is also non-singular matrix, so its inverse exists. Sometimes this question uh, can be asked that which matrix in which matrix an inverse exists and in which it will not exist. So for what you will be doing, you will be finding the determinant of A, that's all. If it is 0, you will be saying inverse cannot be found, inverse does not exist. And if it is equal to and is not equal to 0, you will say that inverse exists. Then now we are going for cofactors, because then we have to find out the adjoint of this matrix. So for that, this is A11. So now A11 will be again this way, leaving this these two. 1 1 means positive sign, 4 3 is a 12, minus 12 0. 1 2 means again negative sign in the middle, so leaving this way, 3 3 2 is a 6, minus 36 is equal to minus 30, and then minus outside because of this 1 2, so it is positive. A13 means a positive sign over here, so leaving these two perpendicularly, 2 2 is a 4, minus 24, so that is minus 20. Then A21 here, this is A21, so leaving this way, so we'll have 3 3 is a 9, minus 4, minus 5, 3 3 is a 9, this one 9, and this minus 5 or minus 4, because of that this 2 1 negative sign, it becomes negative. And A22 means this 4 middle term, leaving this way, so A22 means again positive sign inside, so fourth is a 12, minus 6 to the 12, so 0. A23 means this one, so minus 1 to the power 5 means negative sign will come outside, so leaving this way, 4 to the 8 minus 18, so that is minus 10 inside, because of this 2 3 again negative 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 positive 10. The last row, this 3 1 positive sign, leaving this way, 6 3 is 18 minus 8, so that is equal to plus 10. And then 3 2 means minus 1 to the power A32, this one means minus 1 to the power 5, so this way, leaving these two, so 6 4 is 24, minus 4 20, and because of this negative sign this becomes minus 20. And A33 is last one, so leaving this way both the terms, both the rows, and then 4 4 is 16, and this 4 4 is 16, minus 6 is equal to plus 10. So these all are the cofactors of this matrix A. So now adjoint of matrix A is we have put all these rows in a rows manner and then taking its transpose. So 0 and then 30 in the beginning should be here, and minus 20, then we have taken its transpose, so my 30 and minus 20 went there. And then second one is minus 5 0 and 10, second column, and the third column is 10 minus 20 and then 10. This is called adjoint of this matrix A. Now we have formula for finding the inverse, that is 1 upon determinant of A. Adjoint of matrix A is equal to 1 upon determinant A. Value of determinant A we just found is equal to 50, so that 50 comes here, and then adjoint of A into this matrix whole we have. As I told you earlier, you will not be multiplying this 1 upon 50 inside here. Okay. Now the formula for finding x is equal to A inverse B, that x is equal to A inverse. Value of A inverse is this 1 upon 50 into matrix, so that we wrote here this one up to here, and then into B. Into B means this B matrix, which is here, this B matrix, B matrix. So now multiplying, this is 3 by 3 and this is 3 by 1. So the new order of the resultant matrix will be 3 by 1 only. So 1 upon 50 will be still outside, and then 0 into 60, minus 5 into 90, minus 450, and 10 into 70, this 700, and then this 30 into 60, 1800, 0 into 90, 0, and then minus 20 into this 70, so minus 1400, and then last this row minus 20 into 60, so that is minus 1200, 10 into 90, 900, and 10 into 70, 700. So this we got the product of this matrix and matrix B. Now let us find the solution. Now let us find the solution of this. So 1 upon 50, let us find out the solution of this. 1 upon 50 is still outside, and minus 450 plus 700, 250, 1800 minus 1400, 400, and 9 plus 7, 16 minus 12, 400. Now the time has come where we need to multiply. Now that now the time has come. Now Now the time has come where we need to multiply this 50 inside. So we are going to divide it fully. So 250 divided by 55, 400 divided by 58, and 400 divided by 58. So ultimately we got the solution, that is this x, y, z. X is equal to 5, that we had supposed the cost of 1 kilogram of onion. Y is equal to 8, that is equal to cost of 1 kilogram of wheat, and z is equal to rupees 8, that is cost of 1 kilogram of rice. So what all things we had supposed in the beginning, that we got in the form of the cost of the commodities. So that's all about this question. We have another topic, very small one, that in types of equations, that is linear equations only, in this chapter, whether in two variable, three, or so on, one type of this matrix where equations are involved is homogeneous equations. So let us know what all are homogeneous equations, and how do we come to know by seeing them. So homogeneous system of linear equations. So for this yes, a system of linear equations is homogeneous if all of the constant terms are zero. You just need to remember this particular line. That means what we were writing earlier, that is ax is equal to b. This question is talking about this homogeneous system of linear equations, is talking about that b must be a zero matrix. Means in 10th standard what we were writing like 3x plus 4y is equal to 6, that 6 will always be 0. Right hand side will always be 0. When right hand side is always 0, that system of equation is called homogeneous. That is the meaning of this and name of the equation system. So this first equation, there are n variables and n equations we are writing, a11 x1 like we started earlier, plus a12 x2 plus so on up to a1n xn. The right hand side is 0. So this equation is homogeneous equation. a21 x1 plus a22 x2 plus so on up to a2n xn is again 0. And similarly moving to this way, at last am1 x1 plus am2 x2 plus so on amn. These mn are the surfaces, so xn is equal to 0. So means, now look at here, b matrix is always 0. So a homogeneous system is equivalent to a matrix equation of the form ax is equal to 0. Now what is this a? A is the coefficients of the left hand side of the variables. So a11, a12, a1n, a21, a22, a2n, and am1, am2, and amn are the these all coefficients are the matrix A. So x is all the variables, that is x1, x2, and up to xn. x1 x is where all the variables are involved in this matrix x, x1, x2 and so on, and the right hand side is 0. Now a homogeneous a homogeneous system of linear equations is always consistent. How it is consistent? Because of this right hand side, as it is satisfied by ax is equal to 0, means this right hand side. Here b that is right hand side in case of non-homogeneous equations. In case of non-homogeneous equations means when this 0 is not equal to 0, when here we have 1 2 something like that, then such equations are called non-homogeneous, and when it becomes 0 it is called homogeneous. So x1 x2 xn all are equal to 0 for the solution. This solution is called the zero solution or the trivial solutions in when determinant of A is not equal to 0. There may be solutions where you may not have all variables equal to 0. Okay, so then such solutions called non-zero solutions. That means this x1 x2 xn may not be equal to, all may not be equal to 0. Then these are called non-zero solutions or non-trivial solutions. In this case, determinant of A is equal to 0. So these are very two important conditions. You need to remember these two, that for homogeneous this equations, you need to remember when determinant of A is equal to 0, so there will be non-zero or non-trivial solutions. So sometimes you may have some questions in which you may be asked to find out the trivial solutions. For that, or you may be asked whether trivial solutions are possible. So for that, you will be checking determinant of A. If it is not equal to 0, definitely trivial solutions will be there. Okay, and if it is equal to 0, there will be non-trivial solutions. So this is all about homogeneous linear equations. To solve a linear equation system of linear equations in three variable, especially in your course, actually there are two methods to solve it. One is matrix method, that is by finding its adjoints, cofactor, inverse, and then value of determinant and dividing it by that, and then finding the value of x, y, z. Another method is also there, that is called Cramer's rule. Cramer was the name of the mathematician who had given this formula uh, or the procedures how to find out the this value of x, y, z. In this method, we need not to find out the inverse of the matrix, but certain steps are there which I would like to discuss with you. So let us know about this Cramer's rule for the solution of system of equations. Okay, so through this determinant method, so Cramer has used this determinants only to find out the solution of the linear system of equations. Cramer's rule is a method that uses determinants to solve system of equations that have the same number of equations as variables. What does it mean? If there are two variables x and y, so there will be only two equations. If there are three variables x, y, and z, then there will be three equations to maintain that square matrix or square determinant later on. So then consider the system of two linear equations in two variables, that is a1x, b1y, and c1. And next equation is a2x plus b2y plus b2y is equal to c2. The using solution by Cramer's rule. Now the difference over here in the matrix method and this Cramer's rule is, now we will convert everything into determinant forms. If there are two this thing variables, then there will be three determinant, and then if there are three determinants, three variables, then there will be four determinants. What does it mean? So first of all, that what we were using there in matrix method, that matrix A, that will be denoted here simple determinant, simple D, capital D, we will be denoting it by capital D, and its value will be as a value of determinant D only. Then depending upon the number of variables, for then the next second determinant will be denoted by dx, and then the third one, in this case the last one, will be denoted by dy. Suppose there are three variables, z is also there, then fourth determinant will be denoted by dz. So then directly what we will be doing, here is a particular way of selecting determinants. First is very simple. D means A1, B1, A2, B2. A1, B1, A2, B2. That will be D. So first of all, we will write determinant D is equal to this one, or this one. Then determinant dx means this one. So the variable which we are taking the coefficients, this will be left out, this we will be leaving, and we will start with the right hand side and then coming back to the left hand side. So dx, this then while finding this then while finding this dx determinant, that is first term, so we will leave this coefficients of x, and we will start with the right hand side then coming back to the left hand side. So for dx we'll write c1 c2, then b1 b2. Remember this steps. Then I repeat, d means we will start with the coefficient of x, coefficients of y. Okay, if it is z, then z will also be taken. That is determinant d in Cramer's rule. And then when we are taking determinant x, at that time we directly will start with the right hand side, then we'll come back to the left hand side. Okay, and then when we are taking dy, then y is here. So before that, what is left out? A1, A2. So we'll start with the this previous one, previous to this one. In this case, you can understand in other way also. While taking dx, so suppose we want to take dx. So in that case, we will not take the coefficients of x, but before that, we will take the coefficients of previous terms before that variable. So means now in case of x we don't have anything, so to circular motion we will go to the right hand side. Before that c1 c2 will come, after c1 c2 a1 a2 will come. So for that case we have taken the coefficient of this x, x is left out, and we started with c1 c2, and then we have gone to b1 and b2. Now next is when we are talking about dy. So as I told you, when the particular determinant which we variable is involved, we will take the coefficient, we will start with the coefficients previous to that one. So previous to y we have x, so we'll write with the a1 a2, and then we'll go for c1 c2. And then when we find all these determinants d, dx, dy, dz and so on, then simply dx upon d, dy upon d, dz upon d, or so on, that will be the value of x, value of y, value of z, and that's all. So this method is known as Cramer's rule for the solution of system of equations. So if we are solving for x, the x column is replaced with the constant columns. You understood what is constant? Constant column means the right hand side. If we are solving for y, the y column is replaced with the constant columns. That means this y, after this in place of y will take a c1 c2. So this is 2 by 2. Now let us see what happens with 3 by 3. So in case of 3 by 3, a1x plus b1y plus c1z is equal to d1, a2x b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So now uh, the value of x, as I told you, x will be dx upon d, y will be dy upon d, and z will be dz upon d. So for d, now the general this thing determinant for d, we have a1 b1 c1, a2 b2 c2, a2 b2 c2, and a3 b3 c3. So a3 b3 c3. Now that particular twist in the story that starts from here, dx. When you are talking about dx, I told you will be taking the terms or the constants previous to that particular variable which we are taking. So we are taking x. Now previous to x, we have d1, d2, d3. So while writing dx, we'll start with d1, d2, d3, and then b1, b2, b3, and c1, c2, c3. Okay, clear? Next is dy. Now when we are talking about y, previous to this we have x, so its coefficients are a1, a2, a3. So we have started a1, a2, a3. When you complete a1, a2, a3 first time variables, then immediately the constant terms will come. So a1, a2, a3, as we have written here, a1, a2, and then instead of b1, b2, we have written c1, c2. So here in place of this y dy, we have started with a1, a2, a3, and then d1, d2, d3, and then what is the remaining variable c1, c2, c3. Now, when we are talking about dz, now interesting this one also. So dz, so this previous to that, we will start with that only. Previous to this, and previous to that, this one, all variables we will take. So a1, a2, a3, a1, a2, a3, b1, b2, b3, b1, b2, b3, and then because we have taken z, so z's, this coefficients cannot be taken over here. So d1, d2, d3. So at last we are talking about z, so that is this is z. Z will be replaced by constant terms, that is d1, d2, d3. We are talking about this y, so y will be replaced by constant terms d1, d2, d3, remaining as it is a1, a2, a3, c1, c2, c3. Here also same thing. Got it? And when we are talking about y, so here y already done, and when we are talking about x, this x point is replaced by constant, that is d1, d2, d3, and then remaining as it is same. So clear? I repeat once more. While taking determinant d, while taking determinant d means constant, purely constant. So leaving this right hand side, what all things are there we will involve. We will take this all coefficients into this determinant d. When we are talking about x, so here we will put this right hand side d1, d2, d3, and remaining two will be as it is. When we are talking about y, this y, so dy will be equal. When we are talking about y, so this dy will be replaced by this constant right hand side d1, d2, d3, and rest will be same only. And when we are talking about z, so this third will be replaced by d1, d2, d3, and then the rest of the two will be as it is. This is called Cramer's rule to solve the system of equations by determinant method. Yes, students. Most of the problems already we have taken. So now we are going to start a miscellaneous exercise of this chapter. Hardly few problems are remaining that we will take in this um, today's lesson. Almost both the chapters, chapter number 3, that is matrix, and chapter number 4, that is determinant, both were interrelated, and most of the concept, most of the problems almost over. So now hardly few, let us take some of the problems which are a little different in this miscellaneous exercise. So let us start miscellaneous exercise of this chapter number 4, determinant. In miscellaneous exercise, we take question number first. Question number first says, prove that the adjoining determinant is independent of theta. That means this determinant we have to prove after evaluating, after finding the solution of this determinant, in the answer we get no theta involved there. What does it mean? We have to evaluate it, and its answer should be either purely constant or polynomial, but there should not be a this particular angle theta. So let us start the solution. Since all the columns and all the rows are different, so addition of any two or any particular element or in row wise or column wise doesn't make any sense. So what we are going to do, we will expand it through R1. So we are going to expand it. So let us start with this R1 x times leaving this, when we are taking this R1, so that means first element is this one x leaving this way, and then minus x, this is minus x square, and then 1 into 1 minus 1 over there, and then second element is minus theta, so then leaving this way minus theta, minus sine theta into x, minus x sine theta, and minus cos theta, this one, and the third element which is cos theta, so leaving this way perpendicularly, minus sine theta into 1 minus sine theta, and minus into minus this plus, and x into cos theta, x cos theta. So let us multiply now this result. So we get this minus x square into x minus x cube, and x into minus 1 minus x plus x sine square theta minus minus plus this, and then minus sine theta, minus into minus plus sine theta into cos theta, minus sine theta cos theta, and plus cos square theta into x. So sine theta cos theta plus and minus, so opposite sign, so these two cancel. So we have now x cube minus x, and plus we have taken x common from these two, x cos square theta, x sine square theta. Now this, as you know, this is the identity number 1 of trigonometry, so its value is 1. So we have minus x cube minus x plus x, minus x cube minus x plus x. Now minus x and plus x cancel, so we have minus x cube, so which you can see a negative time of x cube, which is you can, as you can see, there is no theta in this answer, so we can say that this answer is independent of theta, hence proved. What was the question? Okay, so let us start now. Next question, question number 4. If a, b and c are real numbers, it is given, and a determinant b plus c, c plus a plus b, c plus a plus b, b plus c, a plus b, b plus c, c plus a is equal to 0. If a, b, c are real numbers and this determinant, value of this determinant is 0, then what we have to show? We have to prove that either a plus b plus c is equal to 0, sum of all these three, ABC, ABC, or a is equal to b is equal to c. Now just think about this particular statement over here. Either a plus b plus c is equal to 0 or a is equal to b is equal to c. Means what? We must have this a plus b plus c as a one factor, and somewhere here a minus b, then b minus c, and then c minus a as another factor. Then from where we will get these two factors? We will get this determinant solved, and then we must have these two factors. One is a plus b plus c into a minus b, b minus c, c minus a. Then since this determinant is equal to 0, therefore we will say that since we have evaluated this particular determinant only, so therefore the value of this determinant will also be equal to 0. At that moment we will put either first factor is equal to 0 or second factor is equal to 0, then we will get this desired result. So let us proceed. How we will proceed? Before that, you need to think over here. Look at here. This in R1, this column we think about it, B plus C. B how many times? Two times it is coming first and third. C in first and second row and A in second and third row. So if we add these three together, then what will happen? A plus A 2A, C plus C 2C, and B plus B 2B. Similarly here, similarly there, as you can see here, C C A A B B, A and A, B and B, and C and C. So same, we will get first R1 as twice of A plus B plus C. Then we can take that common and let us think about it later. What is that next? So let us start the solution. So this determinant, what was given in the question, same only we have written here, taking this determinant as it was given. Then we will write the operation to do. Then we apply this operation. R1 will change with the help of R1 plus R2 plus R3, as I told you here. That only we did. C plus C 2C, A plus A 2A, and B plus B 2B. Similarly over here, and this R1 is replaced by this R1 plus R2 plus R3. Let us now take common this twice of A plus B plus C from R1. Then what we get? Let us see. Then twice of A plus B plus C we have taken out of the this determinant. Then we have identical element 1 1 1 in the R1. So C plus A plus B, A plus B, B plus C, and B plus C, C plus A are non-one element which are remaining now. Now we need to think about this remaining this A plus B plus C first factor already we got here. Then now we will be thinking about A minus B, B minus C, and C minus A. Almost we got all the things in a simplest manner. Maximums we have here. So now we will be expanding through R1. So expanding through R1 will give us twice of A plus B plus C as it is, and 1 times this one into this way, B minus C, C minus B, and this C minus A into B, C minus A into B minus A over here. Let us calculate it. So twice of A plus B plus C is as it is, and then B into B minus B square minus C square, and then this B into C, and minus minus plus B into C, so twice of BC, and then here also minus BC, and minus minus plus BA, and then minus minus plus AC, and minus minus plus plus into minus minus, so A into A square minus. So go for next step. Twice of A plus B plus C, and this AB we have written here, and twice of BC minus BC is BC, and then CA is this one, and then minus A square here, and B square here, and C square also there. Now we got A square, B square, C square negative, and these terms as a positive, so square of any number cannot be negative in general sense. So what we are going to do, suppose this is identity, for example A minus B whole square, or A square minus B square, whatever it is. In that case also, this identity we should have this 2AB 2BC 2CA. For that we are going to multiply this whole result by this minus 2, or this multiplying with the minus, and this 2 can be taken inside. So it is given that this product of two factors equals to 0. That means either first is equal to 0 or second is equal to 0. So A plus B plus C is equal to 0, or this second factor is equal to 0. Now A plus B plus CA, this second factor we have taken, is equal to 0. Now multiplying by minus 2 both side. So minus 2AB minus 2BC minus 2A, then plus plus plus. Look at here. Now 2A square will be broken into two pieces, A square plus A square. Similarly, B square plus B square, and C square plus C square. What will happen at that time? Since we have 2A square, so here we have 2AB, so 1A square. So that is A 1a we have taken from here and 1b from here, so a square plus b square minus 2ab, this become a minus b whole square, and then 1b from here, 1c from here, this, and minus 2 we see this become b minus c whole square, and 1a from here and 1c from here, c square plus a square minus 2ca, this becomes c minus a whole square. When sum of the three things equals to 0, that means first as well as second and third, all three are zeros. So all three are equal to 0. So we write it is equal to second term is equal to third term is equal to 0. If square of any number is equal to 0, then number must be equal to 0. That means taking square root of both the sides. So it should be, if a minus b whole square is equal to 0, then a minus b must be equal to 0. Similarly, if b minus c whole square is equal to 0, then b minus c is equal to 0. Similarly, c minus a is also 0. If a minus b is 0, b minus c is also 0, and c minus a is also 0, that means all three are equals to 0. So a minus b is equal to b minus c is equal to c minus a is equal to 0. That means, hence, if determinant of a, if any determinant is equal to 0, that particular, then either a plus b plus c, that is first factor, is equal to 0, or second is equal to 0, and second factor gave us a is equal to b is equal to c, hence proved. Remember, this was a very important question, and you should try it twice, thrice. Okay. Now we take another important question, that is question number 12. Question number 12 says, if we have this determinant x, y, z, x square, y square, z square, 1 plus px cube, 1 plus py cube, 1 plus pz cube. Then then prove that 1 plus px, y, z into x minus y, y minus z, and z minus x. Same thing what we did in the previous question also, a minus b, b minus c, and c minus a, something like that. That means, look at here, x minus y, so x minus y minus z, so y minus z, and z minus x, something like that. Those steps we will be following. So we have to use properties of determinant, and then we have to solve it, we have to prove it. So let us go for its solution. So we have this determinant. So in the beginning we had studied properties of determinant. This question can also be solved in that way. What we can do this, as you can see here, C3 is the sum of two elements, 1 plus 1 plus 1 plus. So this whole determinant can be divided into two determinants. So what I mean to say, x square 1, y square 1, z square 1, and then plus x y z, x square y square z square, and then px cube, py cube, pz cube. That can also be done. So that is little lengthy method, so we will go for a little shorter way. So directly that subtracting this y minus x or x minus y, whatever, z minus y or y minus z, that both alternatively as per your convenience you can apply those operations. We'll give two operations here. First one is R2 will change with the help of R2 minus R1, as I told you, y minus x or x minus y, whatever it is, and R3 will change with the help of R3 minus R1. So R2 minus R1 and R3 minus R1. You can also do here, R3 will change with the help of R3 minus R2, or R2 will change with the help of R2 minus R3, and R1 also can be written here, but only two you have to give at a time. At this thing, uh, at once you will be applying only two operations maximum for this subtraction. So let us see what happens next. When we give this operation, we have this determinant. As you can see, this we haven't said anything about R1, so R1 has not changed. So R2 and R3 are going to change. So R2 will change, R2 minus R1. So y minus x, y square minus x square, and 1 cancel out. P is outside, taken common from these two, and y cube minus x cube. Similarly, R3 will change, R3 minus R1. So z minus x here, z square minus x square, and then 1 cancel out, P taken common, and the z cube minus x cube here. So now look at here in this second row and third row, here y minus x, here also y minus x, since a square minus b square can be written as a plus b into a minus b. So y plus x into y minus x. So y minus x, y minus. And here look at here, this is y cube minus x cube. So that means a cube minus b cube. What is that? A minus b into a square plus b square plus ab. So that identity we will use here as well as here also. So now it is equal to y minus x taken common from R2 and z minus x taken common from R3, we get this y minus x and z minus x outside. Now we have first row as it is, second row 1 1, y plus x into y minus x, minus x went out, so y plus x, and p times a square plus b square plus ab, that is remaining inside, and y minus x, that factor we have taken common. Similarly, in the third row also 1 z plus x, p times z square plus x square plus xz. Now look at here, this is very simple. If we subtract these two, will we get 0. So next operation we should have with the help of R3 minus R2. R3 minus R2. So then what will happen? This 0, x will cancel out, x square will cancel, x can be taken common, then yz, whatever it is. So now y minus x, z minus x out. First row as it is, second row as it is, and we have given this operation for R3. So R3 will change with the help of R3 minus R2. 1 minus 1, 0, 0. X cancel, so z minus y, z minus y, and p outside, so p is outside only. Now x square cancel out, so y square minus z square, sorry, z square minus y square, that is factors in a factor form it went. I explain here, z square minus y square, so z minus y into z plus y, a square minus b square, and from these two x taken common, so z minus y. Look at here, z minus y into z plus y, and here z minus y inside into x. So what we are going to do, z minus y taken common, so z minus y went out, and inside from here is y plus z, y plus z, here y plus z, and this x taken common, so that x went here. Okay, now next step is this y minus this y minus x, z minus x, as it was outside. Now z minus y taken common from R3, as you can see here we have 0, so it doesn't make any difference. So z minus y also we have taken common from R3, so R1 R2 as it is, and 0, z minus y went out, so 1 here, and z minus y from here, so that is 1, and p into x plus y plus z. And now I think we have only one option, that is expanding through R3, because here we have 0 and here we have 1. So x minus y, all these three factors outside, 0, first 0, we are expanding through R3, so that means this R3, so 0 into, so this way leaving these two perpendicularly, so 0 into anything 0. Next step is 1, so minus 1 in the middle, because this step is 3 2, so 3 2 will be negative, minus 1 to the power 3 plus 2 5, so that's why it is negative 1. And then leaving this way here, x into p into this one, so what you have to do, x multiplying inside, so y square into this x here, x square into x, x cube, and xy into x, x square y, and p is as it is outside. This way we have multiplied, and minus this way will go this, for this particular structure, this into 1 into 1 plus px cube. So that is, now multiplying this 1 into 1 plus px cube negative time minus time 1 into 1 plus px cube, that will be here minus times 1 plus px cube, and because of this minus that went inside, so this minus and minus become plus, so plus 1 plus px cube. And the last step we have this one, px plus y plus z into, so this way leaving outside, p into x plus y plus z here, and then y plus x into x, so that is xy plus x square. Just for a moment think about it, xy plus x square, and then minus time multiplying this 1 into x square minus x square, this minus x square and this x square plus cancelled, and then this xy only remaining, so that is only outside we have here. Now multiplying inside this minus 1 into p, this came minus px y square minus px cube minus this thing, and then plus so on up to here. Then minus pxy square, and then xy square cancelled, and then px cube, and then px cube plus minus cancelled, and minus px square y, and px square y cancel, and only 1 plus pxyz is remaining. So we write in next step, x minus y, y minus z, z minus x minus y, y minus z, z minus x into 1 plus pxyz. Here one thing you should know, this alternatively we have changed x minus y into y minus z. So taking 1 minus from here common and 1 from here, that becomes plus, and then this has become x minus y, and this has become y minus z. That's why this has been changed, because this was asked in the question x minus y, y minus z, not z minus y. That's why we changed it. So now this is 1 plus x p 1 plus pxy z. So hence proved. Another very interesting question we have, question number 16. Uh, Solve the system of equations. The system we have 2 upon x, 3 upon y, 10 upon z is equal to 4, 4 upon x minus 6 upon y plus 5 upon z is equal to 1, and 6 upon x, 9 upon y minus 20 upon z is equal to 2. We have to solve this system of equation by matrix method. So what is special thing for this question, actually by now number of questions we have solved, everywhere we find whether these questions were in 2 variables or 3, every time this variable was in multiplication form. First time you can see here x, y, z are coming in the denominator. So how we will solve? So for the solution, the same procedure. If it is asked is solve it by matrix method, so we'll take that matrix A, matrix X, and matrix B. So matrix A will be the coefficients of variables. So what is this? 2, 3, 10, 4, minus 6, and 5, 6, 9, minus 20. This should be our matrix A. And matrix X, that is called the involvement of all the variables in the question. So instead of now small x, we were writing small y and small z, that was in column format. So that same thing we will write in whatever it is given in the question, that is capital X matrix is equal to 1 upon x, 1 upon y, and 1 upon z. And the right hand side, the matrix B is 4, 1, 2. So same only. So let us start. So matrix A is, as I told you, 2, 3, 10, 4 minus 6, 5, and 6 9 minus 20, and matrix X, that is variables all involved, 1 upon X, 1 upon Y, 1 upon Z in all three situations, this thing. And matrix B is our right hand side, that is 4 1 2. So now let us find out the value of determinant A, that is this matrix will take its determinant is equal to, leaving this way and expanding through R1, so twice of 20 into 6, 120, minus minus plus minus 45, and then minus 3 over here, so leaving this perpendicularly this way, so minus 20 into 4, 80, minus 80, and 6 5 are minus 30, and then plus 10 at the end, so this way leaving, so 9 4 are 36, and then minus minus plus 36. So solution of this equals to this, and 36 into 2, 72 into 10, 720, which is equal to 1200. And 1200, as you can see, it is not equal to 0, means this matrix is a non-singular matrix. So non-singular matrix means we will have definitely unique solutions. So that therefore its inverse exists. As I told you earlier, for checking inverse existence, we need to see the value of determinant. If it is non-zero, definitely inverse will exist. If it is equal to 0, inverse doesn't exist. Now for the finding of the inverse of matrix, we will go for the cofactors of this matrix. So we'll start with it. So A11, this position 120, minus minus plus 120, minus 45 75. A12 is this one, negative times, so minus 110, so because of that minus, this become positive. A13 is this one, so leaving this 9 4 the 36 plus 36 72. Next step is A21 here, that is A21 leaving this way, so minus 20 is minus 60, and then minus 90, and then 150, and then next is A22 this way, leaving these two, so minus 20 into 2 minus 40, and then minus 10 into 60 minus 100, and A23 means this 5, so leaving this way, 9 2s are 18, minus 6 3s are 18, 18 minus 18 0, so A23 is 0. Now we go for the third this thing row, so A31 we have this 6, so leaving this way, 5 3 is 15 plus 60 75, and A32 this will be negative here over here, 5 2 is a 10 minus 40, so minus 30, and because of this minus plus 30, and A33 is this minus 20, so leaving this way, minus 12 and minus 12, so it is equal to minus 24. Now this we got all the cofactors of the respective elements of this matrix, so we'll put all these elements in the same fashion, and then taking its transpose, that matrix is called adjoint of this matrix. So it should be equal to this adjoint of A, this is adjoint of A, 100. So the inverse of the matrix is equal to 1 upon determinant of A, 1 upon determinant of A into adjoint of matrix A. Adjoint of matrix we will get from these all elements. So that is equal to 1 upon determinant of A, its value is 1200, so 1 upon 1200 into adjoint of A, so means all these elements are horizontally, so for that transpose we will put them in vertically, 75 110 and 72, 150 and a minus 100 and 0 this way, and then 75 and a 30 and then minus 24. So this is the A inverse. We will go for now finding the value of X, capital X, that is equal to A inverse B, standard form. So A inverse is this one into matrix is 4 1 2. So 4 1 2, as I told you, don't multiply this 1 upon 1200 here, and don't multiply here also. A time will come when you will be multiplying these two matrices, and the product will be a matrix of order 3 by 1, or in some cases if it is 2 by 2, then it will be a 2 by 1. Then you multiply it at the end to get the value of the variables. So we will multiply these two. This matrix is of order 3 by 3, and this matrix is of order 3 by 1. So 3 eliminates. So new product of these two will be a matrix of order 3 by 1. So let us multiply these two. 75 into 4, then 150 into 1, then 75 into 2. So 1 upon, and 375 into 4, 300, plus 150 into 1, 150, 75 into 2, 150. Second row, 110 into 4, 440, minus 100 into 1, minus 100, 30 into 2, 60. And the third one is 72 into 4, 228, and 0 into 1, 0, and minus 24 into 2, minus 48. So this is equal to 1 upon 1200, 300 plus 300, 600, 400 minus 100, 300, 300 plus 60, 400 minus 100, 340, and plus 600, 400, 288 minus 48 is equal to 248. Now dividing each term by this 1200, 600 upon 1200, 1 by 2, 400 upon 12. So dividing this matrix by 1200, we get this variable matrix x is equal to 1 upon x, 1 upon y, 1 upon z is equal to 1 upon 2, and 400 upon 1200, 1 upon 3, and 240 upon 120. 0 0 cancel, 24 5 is 120, so 1 upon 5. Hence we got 1 upon x is equal to 1 upon 2, 1 upon y is equal to 1 upon 3, 1 upon z is equal to 1 upon 5. But our question was, we have to find out the value of x, y, z, not 1 upon x. So what we are going to do now, the last step, that is, we will take a reciprocal of these both sides. So what will happen, x 1 upon x, 1 upon 2 will become x is equal to 2, y is equal to 3, and z is equal to 5. Now we take one more question, which is of MCQ nature. So let us start that. We have given this matrix A is equal to 1 sine theta 1 minus sine theta 1 sine theta minus 1 minus sine theta 1, where theta is from 0 to 360 degree. Then we have four options. Option 1, we have to check whether its answer, whether its value is, after finding the determinant of this matrix, determinant of A is equal to 0, or determinant A belongs to 2 to infinite, or determinant A belongs to 2 to 4, means value of this determinant A is between 2 and 4, or its value is equal to 2 or equal to 4, or between them. So let us start its solution. So we have this matrix A. So we have this matrix A. Let us evaluate it. So determinant A is equal to 1, expanding through this R1. So we are leaving this way. So sine theta into sine theta, uh, we will take it 1 into this way, 1 into 1. Uh, so let us evaluate this matrix in the form of determinant. So determinant A is equal to 1 into, leaving this way 2 perpendicular, so 1 minus into minus plus sine square theta, so 1 plus sine square theta, middle term is sine theta, so minus sine theta into, leaving this way, so minus sine theta into 1 minus sine theta, and minus into minus plus sine theta, this one, and the last term is 1, so this way, leaving it outside, 1 into minus minus plus sine square theta, and then minus into minus plus 1. So this minus sine theta plus sine theta cancels, so whole term is equal to 0. So 1 plus sine square theta and 1 plus sine square theta means twice of 1 plus sine square theta we will get. 1 plus 1 2, 2 plus 1 square theta, 1 sine square theta, and 1 sine square theta, 2 sine square theta. Then equals to 2 we are taking common, so 1 plus sine square theta. Then now we are starting with our general concept of trigonometry. Since theta, it is given its value is between 0 to 2 pi, so we will correlate sine theta with it. So as we know that sine theta lies between 0 and 1, that means its minimum value is 0 and maximum value is 1. So our result of this determinant is this one, and general concept of trigonometry is this one. So we will correlate this concept with it. So that means what? So in the middle term, in the middle of this expression, we have sine theta. Here we have 1 plus sine square theta, twice of rather. So what we are going to do, this sine theta will be converted into this result. So first of all, we will square it, then we'll get sine square theta, then 1 plus outside, so we'll add 1 into it, and then twice of this means multiplying throughout by 2. So let us start. So 0 squaring both sides, so 0 square is equal to 0, 1 square is equal to 1, and sine square theta is equal sine theta ka square of sine theta is equal to sine square theta. This now adding 1 throughout in all this 3, so 0 plus 1 1, and 1 plus sine square theta, and 1 plus 1 2. Now we have 2 outside, so multiplying throughout by 2, so we get 2 uh, 2 is less or equal to twice of this, multiplying with it also 2, and 2 to the 4. So that means this particular middle term, twice of 1 plus sine square theta. What is this? This is actually our determinant. That was our matrix A. So value of this matrix we got is this one, 2, and its value is from 2 to 4. So that means this determinant A, twice of 1 plus sine square theta, means determinant A belongs to 2 to 4, from 2 to 4. That means the D option is the right option, right one. So the correct option is D. That's all about this question and about this chapter. I hope you have enjoyed the time and try to solve which some of the steps which I have orally taken, that also you should take, and take sincerely. More sincere efforts are need to be put in this regards, then nobody can stop you from scoring good marks. And marks is the second thing. First of all, you should have a very good knowledge of mathematics. That's all about this chapter. Thank you.